is an important form of energy which is used extensively in every single household in Singapore. Large amount of electricity is used at home, in schools or offices. Hence, it is important to use an energy-saving light bulb so as to conserve energy and to reduce the electrical bill. It is important to conserve energy as most of the electrical energy we obtain are from non-renewable sources which can be used up eventually if it is not used wisely. Our group decided to embark on an investigation to find out which light bulb is the most energy saving and how much energy can be saved in a month. Under the principle of conservation of energy, energy cannot be created or destroyed. It can only be converted from one form to another form. When switching on a light bulb, electrical energy is converted to light energy and heat energy. For a light bulb to be energy saving, its power efficiency must be as high as possible. This means that more electrical energy should be converted to light energy than heat energy. In this investigation, thermometers are used to measure the increase in temperatures near the light bulb for a period of 10 minutes. Using the theory of heat capacity, the amount of heat energy produced is then calculated. The lesser the heat energy produced, the more energy efficient the bulb is. For this investigation, we have assumed that all the electrical energy is converted to light and heat energy, and all the heat energy is produced is assumed to be lost to the surroundings and absorbed by the black metal can. We also assume that the heat capacity of the metal can is negligible. The main focus of this project is to determine the most energy efficient bulb and how efficient it is compared to other bulbs. Hence, the percentage of efficiency of each bulb will also be calculated.
We use laboratory thermometer, stopwatch, table lamp, and black metal can. The thermometer measures the change in temperature, while the stopwatch monitors the time taken for the temperature change. 3 different brands of light bulbs are used in this experiment, namely the tungsten filament light bulb, Philips energy saving light bulb, and Panasonic energy saving light bulb. We followed these procedures. First, we fixed the tungsten filament light bulb in the table lamp. Then we placed the thermometer in the black metal can and put it close to the lamp such that it is 5 cm away from the lamp. Then we measured and record the initial temperature. After that, we switched on the lamp and start the stopwatch together. 10 minutes later, we recorded the temperature again. Then we repeated step 1 to 5 using Philips energy saving light bulb and Panasonic energy saving light bulb. We determined the change in temperature by subtracting the initial temperature from the final temperature. Using the specific heat capacity of air and the change in temperatures to calculate the amount of energy, Q, given out from the light bulb. The energy of the light bulb, E, is also calculated by taking the product of the time, 300 seconds, and the power rating of the bulb. Percentage of efficiency is obtained by subtracting Q from E divided by E times 100%. Comparisons are made using these values.
The following are constant for all 3 bulbs. The volume of air in the metal can is 0.00025 meters cubed. The density of air at 30 degrees Celsius is 1.20 kilograms per meter cubed. The specific heat capacity of air is 1.005 kilojoules per kilogram degrees Celsius. The time taken will be 300 seconds. The heat energy absorbed will then be calculated using the formula below. Mass times specific heat capacity times change in temperature. As for the tungsten light bulb, which is 25 volts, its initial temperature was 30.5 degrees Celsius. Its final temperature was 74.0 degrees Celsius. Thus, its change in temperature is 43.5 degrees Celsius. Its heat energy absorbed would be 0.0131 kilojoules or 13.1 joules. hence its percentage efficiency will be 99.8%. As for Panasonic energy saving light bulb, which is 8 watts, its initial temperature was 31.0 degrees Celsius. Its final temperature was 31.0 degrees Celsius. Thus, its change in temperature is 0.0 degrees Celsius. Its heat energy absorbed would be 0 kilojoules or 0 joules. Hence, its percentage efficiency would be 100%. As for Philips energy saving light bulb, which is 5 watts, its initial temperature was 31.0 degrees Celsius and final temperature of 58.0 degrees Celsius. Thus, its change in temperature is 27.0 degrees Celsius. Its heat energy absorbed would be 0.081 kilojoules or 8.1 joules. Hence, its percentage efficiency would be 99.4.
Chart A shows the comparison of energy between the light bulbs. The tungsten filament light bulb produced the largest amount of heat energy, while no heat energy is given out from the Panasonic bulb. The Philips bulb produced slightly more than half of the amount produced by the tungsten filament bulb. This shows that more electrical energy has been converted to heat energy in the tungsten filament bulb. No electrical energy is converted into heat energy in the Panasonic bulb. However, these bulbs have different power rating. Thus, it would be a fairer comparison to use the percentage of efficiency. Chart B shows the comparison of efficiency. The Panasonic bulb has the highest percentage of efficiency, while Philips bulb has the lowest. However, all three bulbs have very close values and fall within a range of 99% to 100%. The results from the findings show that the Panasonic bulb loses the least energy. Hence, it is the most energy-saving bulb among the three bulbs.
There are a lot of limitations to this experiment. Not all energy loss was effectively captured in the experiment. The experiment should be best carried out in an insulated environment in order to obtain a more accurate result. Although the results shows that the Panasonic bulb is the best, we did not expect it to be 100% efficient. To resolve this, the experiment can be carried out over a longer period of time instead of 10 minutes. This is because one possible reason why the Panasonic bulb shows no loss of heat is that the heat given off by the Panasonic bulb is so low that it is not enough to heat up the air around it within 10 minutes. Hence, longer time is required to observe such result for the Panasonic bulb. The analysis shows that the tungsten filament bulb produced more heat energy than the Philips bulb, but its percentage efficiency is slightly better than the Philips bulb. The reason for this is because the power rating for the tungsten bulb is 25 watts, 5 times greater than that of the Philips bulb, but its heat loss is less than 5 times of that of the Philips bulb. More tests are required to prove that the Philips bulb is more energy saving than the tungsten filament bulb. For instance, tests of the light intensity. Both of these bulbs may be producing the same light intensity, but the one with the lower power rating will be more energy saving as it uses lesser amount of energy to produce the same light intensity.